Good afternoon, everyone, and thanks for joining. The webinar is going to start very soon. We're going to wait for 1 minute then before we get started. Our speaker is here. Yeah, so I guess we can start now. Others are going to join us on the way. So yeah, good day everyone, and welcome to the second edition of our monthly webinar. So we had this same webinar last week, and then we spoke about AI and ML, how to get started. But because of time, so we were unable to finish everything that our speaker wanted to like speak to us about. So that is why we just said we'll just have like a second version of this thing so that we can cover the parts that we were unable to finish last week, and then we can just round up everything. So yeah, so we are going to get started now, and then we can now continue from where we stopped. And also, as we have mentioned, I think we did a little bit of a live session yesterday. Like, I'm also going to have something similar to that today as well. So yeah, so let's get started. So our speaker is here. I don't know if I should still do like an introduction or we were all here last week. So our speaker here is now, his name is Salim Unyola, and he's a GitHub campus expert and also an AI ML engineer, also a student of Unilag, and he has a lot of experience when it comes to AI and machine learning. So yeah, so he's going to start with us now, and so the floor is now yours, Salim.
Thank you very much for the warm welcome. I really, really appreciate. Also, really excited to be here again. I had so much fun last week. Talking about AI and ML, and I look forward to just continuing it. But before we get into like the nitty gritty of today's session, let's just have a quick recap for perhaps anyone that wasn't in the last session. Just talk about the things we talked about, probably like 5-10 minutes. We just recap. And thereafter, today we just go all the way to the live coding session where we would work on two ML models. I think last week we were able to work on a simple regression model. But yeah, in case you were not here last week, missing regression will be a bit here and there. So I think I started by defining what AI or ML is. So just to be sure, can you hear me?
Yeah, I can. So you can also hear him. You can just react. Just send the reaction.
All right then. All good, I guess. Alright, so we spoke about AI and ML. We talked about, I think This probably I don't think there's ever been a point in the history of the world where it's been this educated about AI, or more accurately, where AI has been this generally accessible. A couple of years back was a concept of AGI that was out there in terms of artificial general intelligence, in the sense that um I think more accurately, even before the chat, that was probably before November 2022. Everything we talked about in the context of AI was usually in the academic context. It was either like people just talking about it from a contextual point of view, like okay, there's this content from a conceptual point of view, rather. Okay, there's this concept that this and that, but never really in the practical sense, never really in the part where every Jack and Harry can have access to these AI models, or use it for their day to day. However, I think I spoke about this last week. How with the advent of, or with the introduction of ChatGPT, that's where I think ChatGPT, in my opinion, was a big turn for us. Where okay, now by just creating a Gmail account with OpenAI, you can then have access to um a 70 billion token model. So, like I think that was a big one for the AGI for AGI, right? So I talked about that. Thereafter, I talked about how at the core of machine learning, or at the core of AI is machine learning, at the core of machine learning is math. I was able to draw a bit of inference in the sense that there are two types of machine learning. We have supervised and unsupervised. Supervised would be when you have your machine learning model such that it knows the label targets, and unsupervised would be when there's no label targets, right? I also spoke about how so give me a second, please. Okay, yeah. I spoke about how the best analogy I can give of how machine learning works is what you're doing when you say machine learning is just basically like teaching a computer to think the way humans think, and you have to ask yourself, how do we as humans think? I remember I threw that question open to the entire audience last week, and a handful of the responses were around examples and experiences, and that's very right. As humans, we learn from examples, we learn from experiences. Okay, and if you were to train a computer to also think the way humans think, I mean, it's no brainer that would also train the computer to learn from experiences. So machine learning textbook's definition would be training a computer to make things we probably think of as intelligence in human, right? Training a computer to do that without explicitly training it. So the same way as humans, we are not explicitly like you don't. For instance, yeah, this is a good one here. Let's say you have an infant, say 9 year old, 9 months old rather, and you have him or her crawling around the house. I don't think most 9 month old kids, I'm not sure they can walk. I don't think they can, yeah. So you have him or her walking or crawling around the house. And then I think I gave an instance of a lantern, and the child touches it. Obviously, there'll be a response to stimuli. And when that happens, the child probably cry, the way kids are now, probably have the entire response. Now, the next time the child sees a lantern, the rest assured that he will not touch it, or he or she will not touch the lantern. Now, that's a literal learning experience there. However, when I say explicitly programmed, is the child does not really clock that thing is called a lantern. As an adult, as an adult, I know that's a lantern. So if I were to learn as an adult, I'll probably learn something like, "Don't touch that thing. It's called a lantern." But then the child doesn't explicitly doesn't learn that thing explicitly. What it learns about instead is the features of the lantern. Probably learns that okay, yeah, there's this silver thingy that's probably placed in X and Y place in the house that has transparent um that's transparent in the middle, and has a glow coming out of it. That's what the child clocks. That's what the child learns. The child does not learn that okay, this is a lantern. Doesn't learn the name. If we're learning the name, that have been explicitly programmed, right? However, what the child learns instead is you're just learning features of that thing. In the same sense, too, that's how machine learning models are trained. They learn features. Okay, they don't learn. You're not explicitly training that this one is this one. Just learn from a feature. Furthermore, I talked about how there are two different types, self supervised and unsupervised learning. And one key thing I touched on before I touched on supervised and unsupervised learning was the concept of large language models, which I also just touched a bit here as well today. Now, supervised learning models are models where you know where you're going to, you know your targets. I think I gave an instance of your just as two math teacher coming into the class, and then it gives you let's say 10 quadratic equations, tells you to find the x values. Yeah, that little thing, that's your training data there. It trains you on those, probably like gives you 15, 20 data, 20 equations, asking you to find their what's what I'm looking for? Find their roots. Yeah, what do we use roots? Find the roots of those equations. Afterwards, and it gives you a couple of examples for you to then like. So basically, he's just training you with those examples. You see how I did this one. Now do yours. That's the same way supervised learning works. So a good instance of supervised learning would be, for instance, let's say I was training a model to, let's say I'm a real estate person, for instance. Yeah, I want a good machine learning model that's based on a couple of things can tell me the predicted range of prices for a house. Okay, so for that kind of instance, I'll probably want to get the location of the house. Obviously, I'm using the Lagos context. Houses in Ikoyi is not the same to houses with Agege, right? So also want to put in the location, number of bedrooms, number of bathrooms. Maybe it's a bungalow, that's house type. If it's a duplex, story building, um, if it's you also want to consider things like binary output, like if the house has electricity, if it has water, things like that, right? So what your data set will look like for that would be you have a database of houses with those features. After having those features, then you're going to have your answer. You have like a data set as answer. Afterwards, you can then save it to the real estate, the realtor, that can then be able to serve the model like okay, now you can predict for new use cases. That's exactly how it works. That's exactly how it works. Now that that's done, now that's done, another end of that is unsupervised learning. I think the best analogy for unsupervised learning would be anomaly detection or recommender systems. So a handful of us here um use YouTube or perhaps Netflix, and you realize, okay, for instance, I think I talked about this even last week here. How I'm not a big fan of anime, but let's say I have a friend that loves anime, and the friend uses my YouTube account, watches random. I remember even seeing Attack on Titans, right? Watches a random Attack on Titans video. It won't be surprising if I then go to my feed 2 days later, my YouTube feed that is, and I see videos around Colossal Titan or something, So now, like, because the model has learned from that, now that little experience there is a form of machine learning. It's an unsupervised learning model. It's a recommender system, or it might even qualify as federated learning, right? Now, what's happening there ultimately is that in that context, the data is not the model does not have the target. It doesn't know where it's going to. But what it does is it clusters it. So probably looks at other people that okay, who else is working? Who else has watched this Attack on Titan video? And then what was this person watching? Right. Once you have those things clustered together, then you can learn. Okay, now since the other guys are watching this, you also have this. If you miss like that's something also worthy of note um in the context of unsupervised learning. Yeah, in the context of unsupervised learning. Other instances of unsupervised learning is also clustering algorithms. I remember also giving an instance of, let's say you're trying to get buildings with the same energy profiles, cluster together. Give the instance of let's say you're trying to get people that have been in contact with each other in during the COVID-19 era, and you get the longitude and latitude data of that particular area. I think what we had then was 6 meters, and then get people within that 6 meter that have been in contact, that close to each other. That's another good instance. So yeah, that's another good instance. Finally, I talked about supervised learning being then distributed. So like let's go all the way back to the top, right? At top of the tree is AI. Then a subset of AI is machine learning, right? Now machine learning is then divided into two: supervised and unsupervised. Three actually. There's reinforcement learning, but like let's just stick to the major two here would be supervised and unsupervised. Now supervised is the anomaly detection, clustering systems. Unsupervised is then divided into two. That's regression and classification, right? So regression models are models where the targets, again, remember that supervised machine learning models are models that label target data, right? Now, what will then distinguish regression from classification will be the sense that with regression, they're trying to get a continuous value, right? While with classification, trying to get a discrete value. Discrete continuous. What that means ultimately is, I think using examples will actually shed more light into that, right? With regression, yes, you are predicting house prices. That's a regression model. Let's say you are predicting car prices. That's regression. Let's say I feel like you want to like because the cap price can be 1,010,000 naira, and it can be 1,009,000 naira. Like it's continuous. There's like an infinite amount of values can be. Okay, it can be 1 million. Admittedly, 1,000,000 2 naira and 5 kobo is different from 1,000,000 2 naira and 6 kobo. Like it goes all the way
Sally,
down. Like the infinite.
Sally,
Yeah,
sorry for cutting you short. We are not
yeah,
sharing your screen yet, so I don't know. Maybe you forgot that
yeah,
or
yeah,
not.
yeah, yeah. I know. I'll share my screen right away.
Okay, no
I just
problem.
need to like go through the recap from yesterday, from last week rather. The afterwards, I'll just share my screen. Go on like mainly what
Oh,
I'll share my screen on today will be the code base.
okay, okay. Thank you.
Yeah, I think I sent the slide eventually last week. So we can just go through that slide.
Yeah, you can continue. Sorry. You are muted, though, in case you are speaking.
So yeah, I was talking about LLMs, right? And I said ultimately, I'm just going to like try to wrap up, right? And ultimately with LLMs, what happens is whether it's ChatGPT, Claude Perplexity, Twitter's Grok, ultimately they're trained on large language models. And there's a common conversation around if ML models or if LM models are sentient, and the short answer to that is they're not sentient because they're just trained on past data. Okay, guys. So now I'm just going to share my screen. We'll have a code session where we'll train two models. One is simple regression model and one is simple classification model. Just to, I know I've spoken a lot, but now I'm just going to like add a bit of context to everything I've said, which mainly was a recap of our session last week. So just give me a second. Let me share my screen. Might take a while though. All right, I'll share my screen now. I had to transfer from one PC to another. So let me just do. Okay. All right. So finally, let's have a quick code session. Again, let's work with collab. Okay. So give me a second, please. Let's start with the classification model. This was the model we worked on last week, I think. This was one we worked on last week. Let's just walk through what we did again last week. I'm not sure I still have that data set too, but let's. So this is what we worked on last week. We worked on the fault detection system. Let's see if I can still get this data. We basically worked on the fault detection system last week. And wait a second, please. I really doubt I have it. Let's see. I don't think I have the data set still. I do actually, yeah, it's the data set. I did. So what we did last week was we started by importing NumPy, pandas, all third-party modules on Python. Then we did just importing necessary libraries, right? Thereafter, I was able to import this. This was the data set we had, and okay, I need to start from the beginning. Let's import this. And basically, what I did here was me just I wanted to see what the first five columns of the first five rows actually of the data set looks like. So we have voltage, current, power factor, temperature, light intensity, and time of the day. Time of the day being a decimal value from 0 to 24. That's like just okay, this 24 hours, and now we have a column for the past faults. So this little instance is an unsupervised machine learning model in the sense that you have everything you need that we think might be able to affect the fault. So the factors that normally affect if there's a fault in the system includes voltage, current, power factor, temperature, light intensity, and time of the day. Now I haven't done that. You can then drop some columns. So I made the X. It's just I think the analogy also gave is similar to the. Let me just make a quick drawing here so you can have like this kind of text what I'm trying to do. Let's open this. So you can think of it like the common. Let me draw. Okay. Let's make this smaller and let's make this black. So you can think about it in the context of we have this and we have this. Okay, my drawing is bad. Then we have something like this, and then on the other end you have something like this. Okay, let's assume this x and y axis, right? And what we're doing ultimately is you have a line, you have like this y, and then you have points like this, you have points like this, so you have a point like this, and then you have a point like this. Although this is a two-dimensional context, what a machine learning model does ultimately is why we like the basic linear regression models is that it draws a line of best fits. So forgive my line, but then just a line of best fits. Similar, I think for the science students here, you might be familiar with this from what we do in physics practical. So the goal is to minimize the gap between this and this. That's the entire goal of ML model, minimizing this gap. And that's why you talk about a lot about optimization in machine learning context, talk about convex optimization. So the big goal is, again, forgive my drawing. Let me try to do something neater. Okay, we have this. We have this. Oh, this is actually good. So I can actually join them. We have this, 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 this. And then what you do is you're going to draw a line from here all the way down here. So just a line that's like the line of best fit. That's what you do, but a straight line. So in the same context, now this being a regression, a classification context, because it's either it has fault or does not have fault. So you start by splitting into X and Y plane. Thereafter, you want to divide into like test and training sets. Test and training sets because you want to be able to train a machine learning model is good, but then that's not good enough. You have to be able to train such that you can as able to train and then you can test it. Like you have to be able to know how does my model do. So we have a 80-20 split here. Such that 80% of the data is used for training and 20% is used for test. Finally, you can then train the whole model here. I haven't done all that, and you can get the accuracy. So this is me just picking a random model. You have a logistic regression model. It's a pretty basic model. Also, it's important to note that I think as I was keen on sending a couple of resources last week, there are different classification models. You have random forest, gradient boosting, XGBoost, cat boost, and the rest. But then the most basic classification model is logistic regression. The most basic regression model is linear regression. So I then train the data on the ML on the data, and I have this. Now, what I can then do is because picking back to the instance I gave with the secondary school teacher that talks about quadratic equations, after they've given you the examples, what we'll be able to do at this point in our line of code is we're able to train it. It's like we're giving an example. Okay, look at this. Look at what this data set looks like. You have a voltage of 223 volts. You have current of 7. You have power of 1.75, power factor of 0.94, temperature of 24.44, light intensity of 86%, and then time of the day is around 4 a.m. This was a fault that we had. There was no fault at this point. So like you have that data already. Having had that data, right? You can then train on new. Like you've seen all that. You've think about it as like example one for your math teacher. Not like you've done all that. This is a classwork point. Okay, now okay, you've seen all that. Now let's train you because also thinking about machine learning from a product point of view. This I mean, nobody's going to come and check your model, your ML model on your PC or something. Your deliverable to the end user would be a product like this. So let's just have this product. We have 220 volts. Let's have current as 5. That leaves our power at something at 1.1. I'm guessing. Yeah. The power factor, let's go with 0.95. Our temperature, let's go with 25 degrees. Let's go with light intensity of 50%. Time of the day, let's work with 7 a.m. Let's work with 7 a.m. at least. Then prediction is 0. You see, it just prints all the way out. So that's a simple linear. That's a simple classification model. Now, does anyone have any question? I can also just show a simple regression model, and then we can move from there. At this point, does anyone have any question?
Yeah, if anyone has any question, you can just unmute yourself and just ask your question, or you can also send it to the chat as well.
Okay, I think you have any question. Okay, so let's just work on a quick coding session for a regression model. So I think a common instance that's being used in regression is predicting house prices. So let's just generate okay, let's import the California house price data sets and display the first 5 rows. So yeah, this is an inbuilt. Okay, no. Does this come already? Okay, let's just also price data sets CSV. I was hoping I'll get a good. Okay, let's work with this. I don't have to deal with all that. I should have cleaned this data. Just give me a second, please. Just get good data sets. Because ultimately, for you to train your model, you need good data sets. Something too big as well. Just okay. Yeah. Okay. Let's do this instead. Code to generate synthetic housing price data sets with numerical files. Okay. Yeah, let's work with this. And give me a second, please. Okay, yeah. So now about these assets, I'm going to generate one. Let's rename it to housing data. Rename it to housing the server. Housing the server. And then we have Salim equals to pd.read CSV. And you want to open the bracket of oh yeah, it's nice. And then you have Salim.add, right? Okay, but instead of doing all that, let's have something like I know I renamed it. Just give me a second. Okay, so yeah, we see what the house looks like. So he has the house size, the lot size, the bedroom, bathroom, the year was built, and then the price. Okay, so we have this is our data set already. So following the same thing we did there, let's just have this to train. Again, there are different machine learning models, there are different regression models. We have, but the most basic of them all is the regression model. So again, I'll start with the basic one, that's regression, linear regression. After seeing what the linear regression does, then you can then try other forms. So you're equal to train a linear regression model such that it predicts the house prices and also allows for users models to predict the use of the model. Let's try this. And then once it's done training, I'll also walk us through this block of code and let's so you can just understand what's going on. But then ultimately, okay, I think sometimes I also want to do is share this file. Okay, yeah. So now let's add a value for the square house. Let's go 2000 square meters. Let's have lot size that has 800. Let's have number of bedrooms. Let's make it a 5 bedroom. 5 bedrooms, 4 bathrooms. Let's have it built in 1997. And then we can see that based on that, they also cost $505,000 or naira or whatever this unit of currency is. So basically, I've been able to show us, like I think what I tried to do my plan for last week's session was one to show a classification model, which I did last week, and I eventually just add finishing touches on it today. Furthermore, just trying to also work on a simple regression model so you can also see how it works. Now, rest assured that there are other models like you can use linear regression models and logistic linear regression models and classification models. However, from a very high level, these are the models you can do. Now, one thing I would like to do is one, do you have any questions? In the absence of any questions, I'll just run through the line of code and also share this notebook. You can just like go through it. So do you have any questions at this point as well? Any questions?
So if there's any question, you can just unmute yourself, or you can just send the question to the chat as well. Anyone, I think it's fine.
All right, then. After any question, I'll just run through the line of code, and I guess that should be it. All right, guys, let's work. All right, let's run through the line of code. I think that's the last thing we want to do. All right, so walking through it once again. The code for the classification model is not very different from for the regression model. So after importing necessary libraries, you want to load the data sets, and just what we have here is just synthetic to check if there's actually the data set is available. Just a simple try and accept, just precautionary, right? So just to make sure, okay, to make up for although there's standard errors in Python, trying a file not found error so that you know what's happening immediately, right? That's why having that try accepts function there. Thereafter, I divided the data into x and y column, where x is like x. And you can also think about it from in the context of maths, right? What would x normally represent in the sense that y being a function of for y being f of x, a function of x, right? So what we're doing here is not very different from that, right? And in that same context, that's why I'm dividing x and y, where y is the price, y is what we're looking for, y is the price of the house, and everything that's on the price of the house is that's what's determining y. Now we go for x, right? Having done that, we then want to divide our data set into test and train data sets. Again, the 80/20, although with everything in machine learning actually is something worthy of note, right? There's hardly a one fits all rule. There's no rule of thumb or anything. With every use case, it's different. So what works here might not work there. So I was going to say, although you find a lot of people using the 20/80 split for the test and training data sets, there's really no one fit all. Like you could have, if for instance I have a very small data set, I think a 50/50 split might be better because that way I can actually like test it better that way as opposed to an 80/20 split. So that's just something to take note of. And then you have me training my model here by creating an instance of the model as linear regression, then fitting it with the train and the X train and Y train. Notice that now the model has not seen the test data, it has only seen the one it's being trained on. So it doesn't know, like, you can think of it as how your math teacher will not give you the things will give you your example, not be things will give you as your classwork. So you want to make sure it doesn't see the things like, so like, because that context, that concept is called data leakage. So you want to make sure you have no data leakage, right? So after doing that, you will then also I need to be able to compute my my model's accuracy. How well is it doing? So now for regression models, you tend to compute accuracy in the context of errors. So you have the mean squared error, you have the mean absolute squared error, that's MSC, you have MESC, that's mean absolute squared error. You have MPE, that's mean percentage squared error, and you have MEPE, that's mean absolute percentage error, right? And look, as big as this was my sound, the big idea is just to make sure you're minimizing. Going back to the diagram I have here again, it's just minimizing the gap between these two guys. Like in the graphical context, what I'm doing is just minimizing this gap. That's the back and forth of everything you're doing. And from a mathematical or from a coding point of view, more accurately, yeah, what I'm trying to do is just the lesser that value, the better your model is doing. Okay, so obviously, that's pretty intuitive in the sense that the lower your error, the better your model. Like you're not training your model to have big error or something of the sort, right? I haven't done that. You then created it predicts house prices model. And what it does is simple. It takes in value. Once it takes in the value, it then passes it through the, you see, it goes through the source line here. The one I'm highlighting here. It goes through the prediction equals to model that predicts a new value. Thereafter it prints the new value as predicted house prices, and you have it down here, and yeah, that's pretty standard, and you have the model working well. I think that's a line-to-line explanation of the code, and you see that it's not very different from what we did in the classification model that we talked about last week. So once again, I think in this session, I was really keen on, and I wanted this session to be longer, but then I'm not doing very well with my laptop's battery now. So what I was just keen on doing is just making sure I have a run through of the classification and regression model, having a good recap for anyone that was in the last session. And I think one key thing I'll be doing here, that's why I saved the model, the notebook. Yeah. One key thing I also want to do after this session is also share this. Okay. So perhaps later on, I might just add more blocks of code, and I can also add notes in here. So make it much more explanatory and add text in here, such that you have a line-to-line explanation of understanding of what the code base does. I'll also be sharing the data sets. I'll download right away. And I'll share with I think I'm in the community now, so I'll make sure I share it. And if you have any questions, please be sure to just call my attention to it. I'll be very willing. I'll be glad to help as well. So one last time, do you have any questions? I was really keen on having this. I think I was pretty keen on having this session not last too long. Do you have any questions?
Okay, thank you so much. So yeah, um, as our speaker said, so we are going to be rounding up the this session like in a few minutes. So in case maybe any of us have any question, maybe based on what has been done, the example that showed us, or maybe any other thing that we think maybe even maybe it's just generally about machine learning generally or about AI or maybe anything that we think we have always wanted to ask question about, okay, how are these things being done, or how are these models being trained, or how, what do they do, or even how can I get started? Say, what's the first thing I can say I want to learn? If I want to do, I want to get started with AI ML. So any question we can just quickly ask. You can send it to the chat, or we can just unmute ourselves and ask. And also, as I said, it's also on the community now. So in case any of us, in case you have any question, you can also drop it on the group. And most of the materials that used is going to also share it with us on the group as well, so that we can also have access to everything. So the floor is now ours. So if anyone has any question, please let us ask those questions now. So any questions on AI, ML, or any other thing that, or maybe based on the code base that we just shared now as well, or the example that I showed us, so we can ask those questions now.
All right, guys. Thank you very much. I'll share the slide and the notebook right away.
Yeah, so it seems we don't have any question, and I think we are going to round it up here. So, but before we go, I'm going to send the link to the group now so that we can all help us fill in the form and then just give us our suggestions, maybe based on our next webinar, kind of user that sorry, the kind of speaker I want us to bring, maybe from different from different fields. Maybe from next one, we want us to have a speaker from maybe data analytics or any other thing, so we can just show our interest. Also, I also mentioned last week that we are going to be having our first physical event very soon. So we are also going to make an announcement about that. And also another thing is that maybe we have also heard about it that Google developer group on campus in UI, they are going to be having what's it called? Tech Quest 2.0. So we're also happy to announce that we're also one of their partners for that event. And also we're also going to be hosting our own physical events very soon as well. Everything is going to happen before the end of this week. So let us make sure that we are prepared and then we all attend the event. So if there are no questions, we are going to round it up here. And if you have another question, probably later or anytime, you can also drop it on the group as well because our speaker is also on the group now. So if you have any questions, you can just drop it there. So thank you all for joining. Yeah, the recording for this session is going to be provided very soon. Same thing for the last one that we did last week as well. So the one for last week and the one for this week is going to be provided very soon. So thank you all for joining and see you next time. 2 points.